Right. It's live? It's live? Okay. Hello. There's a little bit of a lag. I am thinking that the review session won't last more than 2 hours. I have never done it with this many people before, so I'm going to see how this works out. Hello, everyone from Ravi, Alvin, Suraj, Vidit, Zubair. Yeah, it's a review, so you don't have to do it. You don't have to listen. It's all optional, and it's just review concepts that we have learned up to be right before 2.6, 2.7. I might touch 2.6, 2.7, hi Priyasha, but I don't know how much I will be able to do in the beginning. Hello, Aditya. All right. Okay, so I am going to start with the basics first, which is the displacement, distance traveled, only because I messed up for some periods. So I just want to clarify and make it kind of clear. Raghav, hello. Okay, so I hope you can see the board. All right. I have to be on my knees for this because I don't have cool things. So, oh, are you serious? All right. Okay, question is, can you see this? Okay, displacement, distance traveled. Oh, so for students who want to take advantage, the best advantage, hi Chirag, of this, you might want to tilt your camera down a bit. All right, I will listen to Robbie. Is that I think the best way to do this is if you know the answers, it's better to type it on the comments or to say it out loud to yourself as I'm talking. That way you're actively learning rather than just passively learning, because I won't know if you're talking because, you know, it's a video. So I think that's the best way. So displacement is basically difference in position. It's your xf minus xo. So basically your final position minus your initial position. And then your distance is your magnitude of displacement. And I will timestamp these. So if you're like, oh, I only need it for one thing, you might want to come back. XF minus XO. So that's the distance. And then distance traveled is your pathway. So this is basically all the little paths that you have taken to get to wherever you are. The best example, I think, is basically running that mile, right? If you run a mile and you come back exactly to where you were, your displacement would be 0. Your distance, because it's this magnitude, would also be 0. So you have ran nothing. But your distance traveled would be 1 mile because you take the entire circumference, or 2 pi r. But I told you it's 1 mile. All right. Any questions on this? This was really quick. So I can move on to the bigger and heavier stuff. Displacement is distance from the origin. You should know it as final minus initial position, because if you know it as distance from the origin, well, I guess there's no issue as long as you're not adding them. That's what I worry about, because it doesn't really matter what the middle path is. The only thing is if the final and the initial is the same. For example, if like your point A and your point B, and it goes like in zigzag order, that's one pathway, and the other way is straight, it doesn't matter for displacement, because all we care is about the final and the initial. So your displacement and your distance would be b minus a, and then distance would be the absolute value, and distance traveled for the curvy one would be much longer than just a straight path from B minus A. Yeah. Okay. I think people get it. Okay, I'm gonna erase this and I move on to average velocity, instantaneous velocity, just the definitions. So we're clear on the definitions between the two and a couple others. I'm very sad that my markers are down. I'll have to get more. Okay. I'll do a blue with hopefully that this is better. Let me get my notes just in order here. Okay, cool. So average velocity versus instantaneous. Instantaneous is such a long word. And then also instantaneous speed and average speed. Okay, so average velocity. Ooh, okay, hold on. There are questions. Here. Yes, distance means how far something is from the origin. Amog, hello. Yes, I think you guys are talking to each other. So displacement would be 0 if you traveled back to the place. The distance would also be 0, but then distance traveled would be however long the path you took, which is what Robbie is saying. Yes, and Suraj is saying. Yes, that's right. Okay, average velocity. So definition of average velocity. So instantaneous velocity and instantaneous speed are very similar. This works just like displacement and distance, where this one, if you take the magnitude, is the instantaneous speed. That is not the case for velocity and speed. So I think that's the kind of difference in the two. So average velocity. Oh wait, I will do the abbreviation because it gets long. Average velocity. Oh, actually, I don't know what the abbreviation for average speed is. So average velocity is difference in distance over time. I mean, displacement. So this is displacement. While average speed is distance traveled over time. So in the case of the mile, this would be different because average velocity, if you ran a full track, would be 0. So average velocity would be 0, but you would have an average speed of however much it takes you. Instantaneous velocity is basically average velocity is the entire distance, the displacement that you take from initial to final to initial. Instantaneous velocity is taking those pieces in smaller frames of time, and you're looking at basically a very, very small and a very short frame of time. How did the velocity change? Okay, and then that's why it's like instantaneous, because it's like you're looking at a very short, in a very short frame of time. What is the change of your displacement, and thus what is your change in time? Okay, and then instantaneous speed, you take in instantaneous velocity, and then you take the magnitude of that. So it's your instantaneous speed, which will be different from average speed. Yeah. Any other questions? Let me see if there is other questions. Okay, cool. Oh, I'll write it down. Velocity taken at short frame, taken at a, how do I word this? Give me a second. I'm losing I want a more exact definition at a very specific instance in time. Yeah, specific instance. It's also really hot in this room, so I'm dying. And then instantaneous velocity, instantaneous speed is magnitude of instantaneous speed. Oh, velocity. Sorry. Instantaneous speed is magnitude of instantaneous velocity. Hi, Charlie. Hi, Monsi. Can you say speed is accelerating since speed is scalar and acceleration is a vector? We don't usually say speed is accelerating, but so I looked up why acceleration does not have a scalar version, and it's just semantics. For some reason, English speaking people decided not to give a scalar version to acceleration. We just call it magnitude of acceleration. So can you say speed is accelerating? Depends on how you're using it, I think. Yeah, and Zubair is right. It's technically the object that is accelerating, but can you say like the object is accelerating even though you're looking at like the scalar versions? Yeah, I think so. Yeah. Okay, so I think this clears up to here. So I'm gonna do deceleration and negative acceleration, which is I think where the confusion is. So let me go to there. All right, are we good? 1, 2. I wait for about 5 seconds because I know there's a lag. Okay, cool. And any questions that are related to the topic at hand, you can ask, and I will pause and try to do it for you. Yeah. Okay. And then deceleration versus negative acceleration. Ah. Okay. Deceleration versus negative acceleration. This one, I am basically using the book example because I thought it was the most clear to giving you examples. It's on page 70. Oh, sorry, 42. So page 42 in your book is what I'm going to refer to later. So if you want to flip to it while you're watching the YouTube, go for it. I will also draw it on here. But first, definitions. So deceleration, it basically means it is the opposite of the motion, meaning it is the opposite of the final velocity. Yeah, it's the opposite of motion. So deceleration. Opposite. Since it is the opposite of motion, it's basically your word you say when you slow down. And how you know it is if your magnitude of your final velocity is smaller than your initial. And it's magnitude. That's the key. Oh, so acceleration is opposite of motion, sorry. It is opposite of motion. Magnitude of your final velocity is smaller than initial velocity. It is magnitude. That's important because I'll show you all the instances. Okay, and then negative acceleration is when the acceleration is negative. So, like the number has like a negative sign. It is accelerating. Acceleration has a negative value. Okay. For this one, basically the final velocity, not the magnitude, but just the final velocity's overall value with the negative sign is smaller. If final velocity, oh, that is terrible. Sorry. Initial. Okay, so can you slow down without negative acceleration? Yeah, this is where I'm gonna go. Yes. So I'm gonna explain it with examples, and I think it would make more sense when there is examples on the board. But I want you to know these definitions because it will help you. So you can have negative acceleration and you can keep going in a negative direction and you're actually speeding up. So it just depends on what is happening. So let me explain. All right, so I'm going to look at page 42 and I'm going to attempt for the first time in my life screen sharing while I'm doing live. I do not know if I can actually do this. Wow, you will not let me share non-Chrome things? How dare you? Hold on. I don't know if I can actually screen share. I'm playing around with software because I am not used to screen sharing stuff on here. So I will do my best. It is page, I said 42, right? Okay, page 42. Let me see if I can actually pop it open on my screen share. I don't know if the screen share will lag my screen. That's what I'm afraid of. Okay, do you see it? Yes. All right, excellent. So basically what I'm gonna do is I'm gonna show you that. All right, so the first example, but that one doesn't have a lot of numbers, which is what I think it confuses me when it's like that. Oh no, if I do that, it goes crazy. Okay, never mind. I don't wanna share if it's like that insane. So I will not screen share. Sorry. So you guys can just look at it. It's on page 42. Because this is going all wonky. Okay, so the first example shows, so in physics, anytime you do physics problems, sorry, I'm like messing around with the live stream and my garage is like opening and closing, so it's like driving me crazy. When you do physics problems, the object is usually written in like a square. So I'm just going to put everything as a square because it's easier than drawing the car. All right. So the velocity in here is going this way, right? And the acceleration is going this way. You know that the definition of acceleration is final velocity minus initial velocity over time. The time we're not going to care for now, but if the velocity is going this way, you can assume one possibility could be that the initial velocity is 5 meters per second. And I'm not gonna have enough room. Final velocity is what, 10 meters per second? Okay. Then if you do the math, pretending that time is like 1, the acceleration would be, or whatever the time is, it would be some positive number, right? Because 10 minus 5 is positive, right? So as you can see, it has a positive acceleration and it's going this way, right? So it's going to be speeding up. Because if you look at just the values without the signs, 5 and 10, it's increasing, right? Anytime the magnitude is increasing, the object is always speeding up, okay? And how you also know that is because you know that it's in the same direction, okay? So speeding up. So speeding up. Okay, then positive acceleration. B example is that it goes from V and then A. So in order to fulfill this, it's going to have VO of 10 meters per second. I'm just going to use very similar numbers so that it's not confusing to you guys. Meters per second, and then acceleration. Then, because it's final minus initial, will be a negative number, right? So this has negative acceleration. Okay, so A is speeding up. This one has negative acceleration, positive accel. And then this one has negative acceleration. And if you look at it, the magnitude of this to this, and do you see how it's going in opposite directions? That tells you that it's it's slowing down. The other way to know it is that the initial and the final, the magnitude of it, this one is smaller. So that also tells you it's slowing down. Okay. All right. These are the easy ones. Okay. Then C. Can I write C and can you guys see C? I think you can. C would be when you have an object that is going in this direction. Oh man, let me do this way. B. And the acceleration is this way, meaning that your VO can be what, negative 10 meters per second. Your negative VF is going to be negative 5 meters per second, and your A is then going to be a positive. Okay, and when you just look at the magnitude, it goes from 10 to 5, which means it is going to slow down. The other way to do it is to look at the arrows. It's going to be one goes this way, one goes this way, so it is going to slow down. So it is a positive acceleration that slows down. Okay. All right. And then D is going to be where the car is going this way for V and this way for A. The only way to make that happen, one of the ways to make that happen is negative 5 meters per second, negative 10 meters per second, and acceleration is going to be then negative, right? And so in this case, when you look at these numbers, right, this one is higher, just the 10, right? So, but if you look at the entire number, right, is negative 10. So you know it's going to have a negative acceleration. The negative and positive acceleration, you look at the entire thing with the sign. The slowing down and speeding up, you only look at it without the sign. So it's negative acceleration, and it is speeding up. So deceleration is only when acceleration and velocity point in opposite directions. Yes. Yes. Which is why I introduced the definition first, because I think it's easier to know the definition. But I think if you know the definition of what an acceleration is, and then not get your negative acceleration and like know what this and this term means, you won't get mixed up. Deceleration is basically a fancy word for slowing down, and we don't have like a speeding upward, although we should. It should be like super acceleration, then maybe people wouldn't be so confused. And then like negative acceleration just is like positive, negative. Yeah. Yeah. Any questions on this one? Yeah. This one, what I would do is take page 42's car example and play around with different numbers. I think that helped me clarify, because I was like, I need to teach these kids. How am I going to teach it? And then when I was plugging in my numbers, that's when I really started, like, it started coming into me. And I was like, okay, I can explain it. So I think if you're able to do it the same way, you are smarter, I believe. So I think you will get it faster. So apply it. Cool. I will wait about 5 seconds before I move on to graphs. Oh, I'm doing it faster than I think. Good. Okay. Jessica. Okay, wait, what? Deceleration, slowing down, right? Yes. Yes. It's a decrease in velocity. Yeah. Yeah, so on the number line, if it's going down. Can something be both deceleration and turning into negative acceleration? Yes. Yes, we have that example. That's why I like this, because it has all of them. So this one, B is your example for that. It's a negative acceleration that is slowing down. Is a decrease in velocity same thing as slowing down? Yes. Decrease in velocity is basically slowing down, which is why I was saying your final, if it's like slower, right? The only thing that confuses people about the concept of slowing down is that, like, if you're looking at negative 20, you would think that number is smaller than negative 10, but they're both negatives, and it's going away from the zero, and if it's going away from the zero, it's increasing in speed. So don't get that mixed up. Does that make sense? So it's the magnitude of the numbers that are basically, if they're smaller. If they're going towards zero, it's basically slowing down. If they're going away from zero, that is when it's speeding up. And I can actually show you this on the graph, which is, I think, the reason why people are so confused when it comes to velocity versus time and trying to do acceleration from it. Yeah, maybe I'll write that down. So overall, the situation is deceleration means slow down. So going towards zero on number line. Okay. And then negative acceleration is when it's just a negative number. So it's just deceleration. I think that's confusing for most students. Yeah. Okay. All right. I think people get it. So, whew, that is one confusing one out of the way. That one was the most, I think, the most asked besides the graph. For the graph, what I'm going to do is I'm going to review kind of slowly what the video went over at first. And I do have a worksheet that I want to show you guys. It's a small, simple one, but I do think maybe extra practice may relieve some people from stress. And I think then I can move on to whatever I said I was doing. So graphical analysis. I think this is where I expect to spend a little bit of time. So if you have questions, let me know. I'm going to do the position versus time, which I think is the easier one. But if you don't understand the position versus time, there's no way you would be able to do the other ones. So I would think let's do this one first. All right. All right. Okay, I am going to basically copy the graph that we saw, a very similar graph. I don't know if I can copy it exactly because it goes in kind of crazy order. Right, and then this one is 2, 4, 6, and then -8. Right. Okay. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is T. This is X. I hope people got that. I haven't finished grading your stuff, but I was worried about some people's graphs. All right. -4. And I hope that's not you. Hold on. Just because an object moves, displacement versus time is decreasing doesn't necessarily mean that distance versus time is decreasing. If displacement versus time is decreasing, hold on. People are asking too many questions. Hold on. Let me address one at a time. Does it necessarily mean no, because distance versus time kind of varies, but at the same time, if the displacement is decreasing, that's like from point A to point B is decreasing. So I would think the distance would, well, it doesn't have to decrease because it depends on your pathway. So no, it's different. That's the question about, unless you're asking distance traveled or distance. If you're asking distance, like as in the magnitude of displacement, yes, that's totally related. If you're asking distance traveled, that depends on the problem. Yu Yang, who I think has a different name on the actual classroom, isn't decreased velocity equal negative velocity? And deceleration, slowing down. Decrease in velocity is negative velocity, yes. And then deceleration equals slowing down equals decrease in the magnitude, which is decrease in speed. Yes, that's right. What if you were going left? Then the velocity would be negative. That's why I said, Robbie, think about it as on the number line if it's going towards zero. If it's going towards zero, which is basically what Yu Yang is saying, decrease in magnitude. If you do that, you are decelerating. But do not think about it as like, oh, if you go left, it's deceleration. That's not right. Because that will not apply when you go negative. Okay? All right. So, this thing, my computer is kind of laggy today. I'm not happy about it. Priyasha is asking me, okay, so hold on. We still have some questions about deceleration. So, oh, Stephen. Hello, Stephen. Okay. Negative 20 velocity. Well, I won't know with just negative 20 velocity because remember, acceleration is a change of velocity. So if you have like, say like negative 10 velocity and then as your initial and your final velocity is negative 20, that is increasing, that is speeding up because the numbers are speeding up. Right? But then if it was flipped, so it was initial was negative 20 and this was negative 10, this number and this number, this is going towards the zero, right? If you draw it on a number line, if this is 0, negative 10, and negative 20, if you're going from here to here, you're going away from the 0, which means you're speeding up. If you're going this way, you are slowing down. Can you have negative speed? No, because speed is your scalar. But you can have negative velocity. Okay? Cool. I'm going to do my graphical analysis. You good, Priyasha? It might take some time to think about it. You can come back to the question as well. I will answer all of the back questions at the end, but I will take it. Yeah. All right. 10. Okay. And then this goes what? This is so annoying to plot. 1, and then 7 to 4. But I like this one, so I will take the, oh my god, this is really long. That's not a good accurate one, but that's okay. 7 to 8, and then it doesn't matter. 2, 6 around here, and then more from 9, more down. Sure, whatever. All right, so okay, great. I think everyone is on board. So what is happening here in terms of the motion? In terms of the motion here, you are looking at, basically this is position, right? So at time equals, so if I was to put it on this kind of a number line, I start at 0 and I'm going to negative 4. And then I am going from negative 4 to 0, right? That's over here at 3 seconds. And then I'm going all the way to 6. I'm going to 6. Okay. And then at 6, from 7 to 8 seconds, I am staying at the same position, meaning I'm not going to move. Okay. So I'm not going to move from here for until 8 seconds. Then when 8 seconds hits, I'm going to go down pretty steeply all the way down to 6. I'm going to go all the way down to 6. And then I'm going to go down more to 8. That's what it would be in terms of if there was a little cart that was moving, that's what it would look like. It would go, woo, 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 woo. Good? Okay. So Now you want to know the fastest, this in relation to speed, right? So this in relation to speed is basically your slope. So you're going to look at the different slopes because it makes sense. You're going from this position. The reason I started with the motion of what the cart looks like is if you're trying to go from, say, like in 1 second from position 6 to -6, you're going to have to go kind of fast, right? And this steep slope shows that, okay? So the fast and the slow speed is determined by your slope. Okay. So fast, slow speed determined by slope of x and t. So your displacement over time is the slope. If your slope is steep, it's fast. That means that you've traveled a lot of distance over a short period of time. Short period of time. Which makes sense because slope of this would be, because of rise over run, it's going to be the x over t, right? That's your slope. Because y over x or rise over run. Right? So if you're looking at the fastest speed, it's going to be this one, between 8 to 9 seconds, for that reason. Okay. For something that is at rest, the slope will be an absolute value for speed. Yes, that is right. Yeah. If I'm asking for velocity, well, even if I'm asking for velocity, like the fastest velocity, it wouldn't matter whether it's negative or positive. At rest, it's going to be the one that's flat because this is going to give me 0 slope, right? Because a horizontal line is 0 in terms of slope. So you got to know a little bit of your math. And your constant speed. Your constant speed is whenever your slope does not change. So it's basically your constant speeds are your straight lines. So this is a constant speed for up to here. And then it does change, but from here to here is constant. From here to here is constant. From here to here is constant. So constant speed is a line on the x to t graph. Fastest velocity, highest magnitude of velocity. Yeah, that is right. Does anybody have any questions on this portion? Okay. If this is the distance graph, how can it be negative? Because 0 is arbitrary. I can set 0 anywhere I want. I can be like, well, my starting point is 0, and if I move backwards, I am in my negative position. That's a good question, though. I think the negative concept confuses students. So, great question. Yeah. All right. I'm going to move on if it's okay. I'm taking a lot of breaks because that's how the live stream and my thing actually has a lag in between. So I just want to make sure you all get it. Okay. The other one asks for basically the difference of the distance displacement from T1 to T10 seconds, and this is T10. Okay. Displacement. And if you're looking for displacement, right, what should you be doing? You are basically looking at the final minus initial position. So it's -8 to -4 because it's at T1. So from T equals 1 to T equals 10. Since the video did that one, we can do like T to 8 to 10, just to spice it up. And if it's like that, the difference in displacement, then it would be 6. 6 being your initial. So this is Final minus initial. So your -8 minus 6. So it'll be 14. Probably meters. Yeah, it's meters. Zero is the x-axis. Oh, Priyasha? I don't quite understand. Okay. And then if you can clarify for me, Priyasha, I will clarify your question, comment for you. Okay. And then it asks for the average velocity. The average velocity is basically your displacement versus over time. Okay. So average velocity, if I'm calculating average velocity, this is going to be your displacement over this differences in time. So if I'm taking that T8 to T10 one, it'll be -14 minus 8 minus 10. Oh, phew. It gave a pretty number. Okay. That's average velocity. However, if I'm looking at instantaneous velocity, that is when I will be taking my slope. Okay. So if I'm taking like instantaneous velocity, say at, well, 7 would be easy because if it's like a 7, you're basically taking the tangent line, right? And whatever points hit this tangent line on this graph. So if I take the tangent line, I'll do the easier one first, so students understand how to do this tangent stuff. So if I'm taking the 7 one, right, I'm looking at what other, if I was to draw a line like this, what other points would hit on this graph? And it will be the 8, right? And so this point is 7, 6, 8, 6. And when you do the math, it will be 6 minus 6, 8 minus 7. So it'll be 0. And it doesn't matter what is on the bottom because it's 0, right? So that's why the instantaneous velocity at 7 is 0. I was just saying for the position, the x-axis represents 0. So when you go below, it is left 0 the number. Yeah, that is right, Priyasha. Okay. So if I was to take something harder, like like 4, okay? Instantaneous velocity at 4. Okay. Instantaneous velocity. Oh, I marked myself at t equals 4 seconds. Okay. At t equals 4 seconds, I am going to draw a line from this point. And it's going to look like that, right? So it's basically this entire line. So you can take any points from that line, because remember, slope is any points along that line. You just take 2 points and you do your rise over run. Hi, Tiffany. What will be the instantaneous velocity for 1 second? We can, for 1 second, it would be, oh, that's a good question. It would be, because it's over here, I think it's 0. It would be 0. Yeah. Is it? So hold on. Let me look. Let me think about this. Good question. -4. Wait, let me do my 4 second first, and then I'll go back to you. I'll have to think about it in 2 seconds, and I'll get it to you. All right. So 4 seconds. So I'm going to just take, I'll take this one. So this is what? 1, -4. And then this one I will take, what, 7, 6. Is that right? And then I will just do my math. So rise over run. And then that should get me some beautiful number. That's kind of ugly, but nevertheless. Yeah. Jessica, and I agree with you, because it's a turning point, because it goes from, at that instantaneous moment, this tangent, Tiffany, going back to your question at 1 second, is at a flat line. So it would be at 0. Wouldn't the area between the intervals represent instantaneous speed? The area between the intervals, no, because we're talking about displacement versus time. In order to get speed, you get slope. Yeah. The area, I'll give you like an overview at the very end as to how to, okay, well, I can give it to you right now. Basically for derivatives and all this stuff, like where do you find the slopes, how it's related to each other. We always have you, there's a reason why in the lab I have you write distance versus time first, and then velocity versus time, and then acceleration versus time. If you go down this way, you're always taking the slope. Okay, if you go up, you're always taking the area. That's how you find it. Yeah, good question, Tiffany, by the way. That made me think. All right, distance to velocity to acceleration, you take the slope. Do you take the slope of this to get velocity? Take the slope of this to get acceleration. Acceleration to velocity, you take the area under the curve. Velocity to distance, you take the area under the curve and you get distance. Yeah, it's always related this way. So you should know that in that order. And it makes sense if you know the units, because it goes from like m to m over s and then m over s squared. The only way to get these units, if the only way to get these units is if you do it this way or this way. That's why. You can try it. I don't think I will, but yes. So slope is easy because it's like meters over second. That's the first one, right? And then the second one would be this over another second. So it will give you acceleration. And then the area under the curve, you would actually have to do some math, but basically it's this time second, this time second, this time second. So it's going to give you whatever you need. I think that was the way. Yeah. But if you do it, it comes out. The units come out. All right. We good about this stuff so that I can plot the VT graph? The VT graph for something that's straight is actually not that bad. I think it's pretty doable. Whenever you get a curve, you can just do an approximation, so it won't be exact, but we don't want exact if we give you a curve. Yes, be good. Okay, so VT. All right, VT. When I look at it, right, you're looking at the slopes, and you're just looking at to see what's positive and negative. Quick preview. Review. If it's going this way, it's positive slope. If it's going this way, it's negative slope. I just remember it on the number line because it's like 1 to 1. The positive ones are passing and the negative ones are passing. If you have a different way to remember it, that'd be good. I remember in high school, I used to get this confused. So anyway, so you know this is negative slope. And then the steepness, if it's really steep, it means that the number is very big. Okay, so steep, big number. Not steep, it's usually a fraction, so small number. Okay, so this one, it depends on what you say. I'm like, oh yeah, it looks kind of at t equals 1. It looks kind of, it's going to be negative for sure, and it's about here. Sure. Okay, I'm just approximating. And then this one, all from t to t7 is going to be a positive slope at a certain level. Okay. And then from 7 to 8, it's going to be 0. So it's over here. And then from 8 to 9, it's really steep, and it's going negative. So, I need more numbers. 8 to 9 is going to be like here. Because it's lower. I know it's lower than 0 to 1. Because compared to this is way steeper. Okay? And then this one is less steep, but it's still in the negative direction. So maybe it's over here. And then you connect it all with a vertical line. That's it for VT. Any questions? And then I want to do velocity, which is, I think, the one that was confusing students. But I actually already explained it, so maybe it will be okay. How are instantaneous speed and velocity represented on the graphs? Okay, let's pause. So instantaneous speed. Instantaneous speed is basically you take one point and you draw a line that's tangent to that curve. okay? And that's the instantaneous speed. The velocity is you just take the displacement over time. So if I'm doing it from 3 to 10, I'm just getting the displacement, which is for here, it would be 0 and -6, right? So final minus initial over the time. That's my velocity. Yeah. Any other questions? Cool. All right, let me do this. All right, I'm gonna do velocity and time. No problem, Suraj. G, because I know I got 2 Surajes. I don't know if they're both present. Okay, I'm gonna take the same graph because I'm that lazy and do the velocity versus time because it's easier. Okay. So for this one, what is happening to the motion, right? You know what is happening to in terms of like which way it's going based on the negative and the positive signs because that tells you the direction. So on the motion, you don't know how far it's going, but from 0, say, you're going in a negative direction. Okay, because it's -4. So it's increasing at -4 direction. It's going to increase until it hits basically -4 meters per second. Okay. Remember that in velocity versus time, away from 0 is increase, speed up. Towards 0 is slow down. Okay. So from 1 to 3 seconds, it's going towards 0. So I am coming back in this direction and I'm slowing down. Okay. No. Am I? Hold on. No, I'm not. I'm going in a negative direction. So all these numbers are still negative. So I am just slowing down, but I'm going in this direction. Sorry. I caught myself. I'm kind of in pre-calc. It's okay, Siraj. I didn't think I really did that well. And you can still do physics. Okay. And I didn't know any derivatives or whatever. So it's fine. You will do just fine. Okay. At time 3, velocity is 0. When velocity is 0, that means there is no motion. It has stopped here. Okay. Then the velocity is being positive. The velocity is positive. It's going to go this way. Okay. And it's going to go this way until it basically hits some velocity of 6. That could be before 0 or after 0. You don't know that. Okay. So at 7 seconds, somehow, you are going to basically hit 6 meters per second. Okay. And 7 to 8 seconds, you are still moving, but you're moving at a constant speed or constant velocity of 6 meters per second in this direction because it's positive. Okay. Then from 8 to about like 8.5, you're still going in a positive direction. So you're going in this way, but you're going towards 0. So you're slowing down. Okay. So you will slow down to a stop at 8.5. Okay. And from 8.5 to 9 seconds, you are going in a negative direction. And you're going until you hit that number. What is it? Like 6 meters per second. And then you constantly go in a negative direction and you're speeding up. You keep going in that direction until you hit -8 meters per second. Does everybody understand this? Because I think this is where students are a little lost. Oh man, being on the floor makes me want to go to sleep. I've never fell asleep in a live stream before, but maybe there's a first. Questions? Concerns? Hi, Roya. Wait, so after t equals 1, you are slowing down, but you're going away from 0, right? So hold on. After t equals 1, you are slowing down, yes, and you're going away, Yes, you're still constantly going in the negative direction. That is correct. Yeah, that's where I got a little confused. Yes. That is correct. So as long as you remember this, and as long as you remember, if it's going in the direction below, it's still going, like negative means negative, whenever you have V, it's going this way. Positive V means this way. Completely changing in 0 seconds on the graph. I don't know what problem that refers to, but we're going to go over every single PowerPoint problems too. That's after this one, I think. I think that's what I said for my schedule. So, all right. Does everybody understand this? I hope this is helping. I don't actually know if it is. I'll ask you guys in class if it is. All right. And I plan to do this. I got a lot of feedback saying that people want lectures. So I realized that it's time. I thought you guys were like, oh, I got it. And I was like, oh, okay. So I didn't give lectures, but I realized it's necessary. So Aishwarya, hello. So I will give lectures. Hold on. Is that because it is negative velocity? Yes. So all of this, from 0 to 3, that's all in negative velocity. This to 8.5 to 11 is all in negative velocity. Besides like 3 and 8.5 at instantaneous, because that's 0. Yes. Okay. Seems like you guys are good. All right. So if you're looking for the one with the fastest speed, okay, fastest speed, it's the same deal. So if it's fastest speed, that means you're just looking for magnitude. Okay. So what has the biggest magnitude? That's going to be at t equals 10 seconds, because that's where it's 8. Okay. At rest means all the 0 points. So 0, 0, 0. Okay. Not this one. This one is at constant. Okay. Constant speed. And anytime you're speeding up is anytime you're going away from the 0, whether that's going down or up. So this way, and then this way. Do you need me to write them down? Was I too fast? Maybe I'll write it down. Fastest speed is about magnitude of V. Okay. And then rest is basically when V equals 0. And then constant, V doesn't change. And then speed up, slow down, speed up is V away from 0. Whatever that means. How would the position versus time graph look for this velocity graph? We're going to do it, I believe. Oh, we don't actually plot it. So it will, I don't know if you guys have to learn how to plot it from this kind of a graph. You should know how to calculate it, like the displacement. So you should take the area under the curve and basically get the answers. You can plot it because of that, but it will be hard because this is gonna give you like a curvy kind of a formula. So I'm gonna say no for now, and then I will confirm. And if you have to, I will teach you, but I don't want to teach you something and may not be something you have to know. But you should know how to calculate the displacement. The calculating displacement area under the curve. Good question, Jessica. I'm going to write your question down, and I'm going to see if you guys need to know that. Displacement versus time from velocity. Graphing. Okay. Thank you. I'm not writing on my chair. I'm writing on a notebook. For anybody who was curious. All right. So from here, you do need to know how to calculate the displacement. And calculating displacement is basically taking the area under the curve. For something like from 1 to 5, it's not that bad because anytime it forms this, because it's area under the curve, it's going to be here and here, which is going to give you a 0, right? So if I'm calculating from like 1 to 6, we'll have a trapezoid. But I will need to basically calculate this area, which is like you take this and then you're going to take the square and then the circle, the triangle. Okay, Aishwarya, there was something about in the book how fixed deceleration takes further to stop. Why does that happen? Can you show me where that is, maybe? You can show me either in person or maybe show me the page from the book so I can read it. Because I remember that for like wet concrete and dry concrete, the deceleration takes a while to stop. But then I'm not 100% sure what you mean by fixed deceleration. So, yeah. Oh, hi, Avi. Okay. Usha. All right. So that's how you do displacement. Displacement is basically area under the curve. I love how you guys help each other. It's helpful to me. And I learn things like that. You guys are nice people. Makes me happy. Yes. Okay. Yeah. So Aishwarya, I want to see it. I definitely want to see it. But I need to maybe know the page number. So you can show me in person, or I will just talk to you tomorrow, and I will ask for it for you. All right. So, velocity average. If I'm taking the average velocity, does everybody understand the area under the curve? This one is the same. It's basically this over t. So if I was like looking from 1 through 6, then it will be like 6 minus 1 and then this area that I got. Okay. And if I was looking at instantaneous velocity, that's really straightforward. Like if I'm looking at like 8, I just look up and I'm like, oh, it's 6 meters per second. So instantaneous velocity is just whatever, it's the point that it is. Okay. And then the average acceleration is basically change in delta v over delta t. And then acceleration would be your slope. Instantaneous one, it would be slope. This would be the point. Like basically on the xy coordinate, the y. Okay. And if we were plotting the acceleration versus time here, it would be the same deal. You get the slope of this, slope of this, slope of this, slope of this, slope of this. So you would get the same exact graph that I plotted for velocity versus time. Okay. Meanwhile, I think what I want to do is show you this whole speed up, slow down thing on the position versus time graph, because I think that was the last one that was discussed. Michael, hi. There's a physics quiz this week, right? Not that I know of, but I could make one. Just kidding. There is a chem quiz this week, but not a physics quiz. But I do think maybe not a real quiz, like maybe like the one we had last time. Yeah. Okay. Okay. So let me tell you are we good about this? Do we get this stuff? Isn't there a test just on next Friday? Yes. It's very sad. One test determines all your stuff. Ugh, that's kind of scary for me. Okay, so I'm going to show you how to interpret the slowing down, speeding up using the x versus the position versus time graph. So slow down, speed up. Ugh. Oh my god, I'm getting so old. Hey, by the way, what are you guys doing right now? Or how was your Labor Day weekend? Speed up. While looking at x versus t graph, determining I'm sitting at my desk reading books. College apps. Oh gosh, you guys are so good. Multitasker. All right. I want to eat. R.I.P. R.I.P. Why are you dying? Okay. Good luck with college apps. You will do fine. You will get in. I think. You're an A. I think you guys will get in. Maybe not to like your dream school, but you can work hard and things will happen. All right. Okay. So the delta X versus T. So I'm going to give you a couple different scenarios. So this is X, T. And then, oh man, I made this one too fat. Oh, I'm too lazy to erase right now. Okay, so from here, how are you going to predict your velocity and your, sorry. Well, I don't want to say like you're definitely going to get in because some people don't. But you will, it will end. It will end. It will all have an ending. Okay, so velocity and acceleration. How are you going to find it? Or how are you going to predict it? Okay, so velocity is basically the slope. So negative slope is going this way, positive slope is going this way. So if you're looking at velocity here, this is all negative slope mostly. So it's going to be negative. And then for this one, it's going to be positive. And then for this one, it's going to be negative in the negative direction. Acceleration is about when you're looking at position versus time, you can look at the smiley faces, which is something that your pre-calc teachers will probably teach you later on, and your calc teachers will definitely teach it to you. If it's smiling, it is positive acceleration. And if it's frowning, for some reason, this reminds me of like a McDonald's commercial. I don't really know why, but nevertheless. All right. So if it's frowning, it's negative acceleration. Positive acceleration, negative acceleration is different from deceleration. So I'm going to also teach you the slow down, speed up as well, which is the last part. Okay. So for this one, it's smiling, right? So it's positive. Okay. If you want to know the actual math behind it, it's because it's going from a negative slope to a 0, right? So it's going to, on a velocity curve, it's going upwards. So remember, acceleration is a change in velocity. So it's a change in the positive direction. That's why it is positive. This one is frowning. It's sad. This is like you guys with college apps. Sorry. Okay, so this one will be negative. Okay. And then this one is also frowning. Maybe this is like Jessica, and then this one's Priyasha. And then this one is, wait, is this one? Yes, this one is negative as well. Okay. All right, the exponential decline is me. All right, this is you guys after we finish our review session. Okay, so after that, you're looking at slowing down and speeding up. Okay, the slowing down and speeding up, you can do it in two different ways. One of them, well, actually, no, there's only one way. The only way to do it is the velocity and the acceleration. Is there a difference in sign? Okay, this one has a difference. So this one is going to be slowed down. Remember deceleration or deceleration. Because deceleration is if these two signs have a difference. Slow down. And this one is speed up. So it does not matter how the graph looks like. It's about interpreting this and then figuring it out. We good? So that now I can do the PowerPoint stuffies. Okay, let me read your comments to see if there was any questions or you guys are just talking about this. All right, you guys look good. I think you're happy. All right, 2.6, 2.7. Oh, let me give you tips on that. Oh, when did I say I was going to give it to you? Just so I can be consistent with this. Okay, I will do the review first, and then I will give you the, worksheets. When are the worksheets due? Hi, Becky. When are the worksheets due? 2.5, 2.8, I think the one you're asking for, that one, I'm not ever going to collect it, to be honest. But if you do it, it will only help you. And then 2.6 and 2.7, I will go over it tomorrow in class. Yeah. Hi. Do we have answers? I hope you have answers. I have answers. In terms of the graphs, I have them. Oh, wait, let me give you the practice questions that I found for graphical analysis before I lose it. This one has answers, so it's quite nice. I will put it up on Google Classroom, and I'll put it up on this one for now so I remember. Okay. That link, the Mayfield School one, is like one that you can practice graphical analysis for if you're like, I'm a little lost. Curve. Don't believe in the curve, guys. All right, you will do fine without the curve. I think. I don't actually know if physics curves anymore. You used to have to, Birdsong, but not sure. Will we have any other quiz like we did on Friday, Aishwarya? Yes, I think so. I just don't want it to take the whole period like the last one, but I do like having them. I just haven't contacted anyone who feels lost and gave me ones. So I need to email and talk to them first so that I can be like, hey, are we caught up? And how do we feel? Because it's my way of just communicating with people one-on-one so people don't feel lost. That's really the goal of that stuff. So yeah. All right. Let me do PowerPoint, if I may. Wait, I have questions. Hi, Roya. Could we have one of those sometimes this week? Yes, I'm willing to give you guys pop quizzes. Yes. I might do actually like exit ticket type of questions, so you guys have one on a daily basis. But yes, is there access to more practice problem with the work done out or like answers to the book problems? Priyasha asked. I am getting the answers to the book problems right now. These people on college stacks or whatever won't approve me as an instructor because I don't exist on the Monte Vista website yet. So they're like, you're not a teacher, you're just trying to get the instructor's manual. And I'm like, no, I'm not. So we're working it out. And then after we work it out, I will get the instructor's manual and I plan to print it and put one in the classroom so that you guys can just have an access to them. I think that will be good. If I get any other hands-on physics textbooks, which I should be able to, I will leave it in the classroom for you guys to use as extra practice. And I do think I'm going to improve the classwork problems. I don't know if I can do that all this week, but I will slowly add them in. All right, so let me do PowerPoints. So PowerPoint questions, I'm going to go over it one by one. This is going to be easy to draw. So let me upload it. How do I upload it? I will upload it to Google Classroom, the one without answers for now, and then I will put up the answers one once I'm done with this review session. Actually, this has answers. It just doesn't have explanation. Sorry, guys. This one's going to take a little bit of time. Give me a second. I need to, like, add a place. Is that how I do it? No, I don't. I don't understand. Save as. PowerPoint. This PC. Desktop. What if I want to create a new folder? Can I do that? Oh, no. It's being dumb. All right. Okay. 2.5, 2.8. And I am going to. So in your Google Classroom, in like 2 seconds, I will create something that you guys can download. Create PowerPoints from last time, from last Friday, and extra practice. And I'm going to go over the extra practice problems here. Do not try to upload this on Google Drive. It like ruins the format, and so you will not be able to see any of the pictures. which is really annoying. Hold on. For section. What the hell? I don't get it. I have too much stuff on my desktop. Oh, I found it. Okay, upload. All right. You will see it now. Okay. I hope it's done in a way where the format isn't broken. By the way, I have a question for all of you guys. I had a student who has been emailing me telling me that she cannot see this week's homework. It's like chapter 3.1 and 6.3, and I learned that it's actually not 3 full chapters. It's basically like all of chapter 2 and then like 3 sections total, and then you have a test. So it's actually not that bad. But can you guys not see on School Loop the homeworks that I posted? Because I can, and it says that I published to you guys, but she says that it's not there. So I don't know what's going on. I don't know if it's just her. No, not homework for like this week. And she was like doing homework for the future. Hi, Krish. I also need to email you. I didn't email you back even though I saw it because I'm discussing it with my other teachers. I get double posted homework. Okay. Maybe I'm getting hers. So nobody can see homework for 9/5, September 5th and September 6th. Oh, what the heck is going on? Okay. I don't know what's going on. All right, I will work on figuring it out as best as I can. If not, I will post it on Google Classroom and see what is happening. It's weird because on mine I have it, but oh, you know what it is? Maybe it's just this. I hate School Loop. Did I not publish it? I did. I don't get it. Okay, I don't know. Whatever. Okay. Well, if anybody sees 3.1, 3.2 for September 5th and September 6th, you can let me know. Okay, some people can see Wednesday's homework. No, it got published. It is published. It says only 5th is visible if you throw it down. Okay. I will see. Maybe I just need to re-click and just click publish again. I will click publish again. See if that helps everybody. That's so frustrating because I already clicked it. Okay. But I'm glad we're doing some troubleshooting because then everybody would be like, we have no homework. But we do. We do. No, we don't have homework due tomorrow. Like I said, it was a 3-day weekend. All right. So if you scroll down, it says it's visible. Avi says he sees it. So maybe it's a functionality issue between, I don't know. Okay. Let me know if other people do not see it by tomorrow, and then we will do some troubleshooting. Meanwhile, when you go to Google Classroom, you will now see the PowerPoints that I have uploaded. Do you guys see it? I'm going to go from 2.1. 3.1 to 3.3. You don't see anything for Thursday if you see Wednesdays because you have block. You see 6.2. Okay. I think it's working. I think it's a little spotty. So if you don't see homework, I will announce homework. And if you don't see homework, I will put up all the links on Classroom. So hopefully it works. But that's annoying because I posted that 2 weeks ago. So I don't know why it's not working. Okay. Can I do the quick checks now? Because we got a lot of quick checks. And I'm going to see however much I can do until 9 o'clock. I usually can make it go longer, but I have a lot of grading for you guys to do. So I want to get on that right now. So quick checks, which is basically your pop quiz on Friday. Not really a pop quiz. You know what it is. All right. I told it to, I think, 5th period, but if you didn't do well on your pop quiz, that's not a bad thing. Because when I have to, say you ask me for a letter of rec, like, if I get to know you on a one-on-one basis because you didn't do well in your pop quiz and then you worked really hard to go up, I have so much stuff to write about you. So it's not a bad thing, actually, to not do well on pop quizzes. So don't be shy if you're not doing well. It's actually not such a bad thing. And if you're doing well, then that's a good thing. No, it's not a real pop quiz. Hence, hello, quotes. Okay. Okay, cool. 2.1. Okay, so 2.1's graph looks like this. It's like a 0. 1, 1. Oh no. 0. And then it's like whoosh, whoosh, whoosh. Okay. What I hate about these is that they do not have like a no grade is entered. That actually counts. Yep, that's exactly right. This formative word, you guys know it. That's cool. Okay. I like having numbers to this stuff because I thought this was really confusing without numbers. So I put in numbers. And then I did, because I was like, oh, it must be like doubled. Okay, and then this is at each time point. So this is t equals 0, and then 1, 2, 3, 4, 5. So the upper part says the time, and the bottom part says the displacement, according to my thing. Okay, so that people know what the position versus the time graph looks like. Okay, so the position versus the time graph, I think if you have all the points written like this, you can actually plug each and every single, or like a couple points in, so that you can find out what the slope looks like, so that I can show you why the slope is the way it is, okay? But before you do any kind of plug and chug, you know that the displacement, this is x and this is t, right? The displacement starts at -3. That means it's going to start on the bottom here, okay? So you can automatically eliminate A and D. So A and D are not your answers because they start at 0, and this thing doesn't start at 0. Okay? And then it's a question of, and then you can actually also eliminate C, because C says that it increases at a very constant rate, but you can see that this is basically half of this increase. So this is going to not be C. Okay? The speed at which something increases, the slope, right? The steepness of the slope has something to do with velocity, right? And velocity is the fastest when distance, there's a large distance covered over a short period of time in this kind of a case, because the time is very consistent here, right? So in this case, this is going to have a steep slope, this part, from T3 to all the way, and T0 to T3 is going to have a slope that's more horizontal, right? And if you look at that, the only one that would work is E. And now I will show it to you on a number scale. So then it would be, so this one would be 0 and 3, -3 over here. And then, oh man, it's better if this is like on a graph paper, but mine is not. -1 to 2. Okay, so this is the line. And then 0 to 3. And then 2, wait, no, 3 to 0, yeah. And then 4, 2, and then 4, no, 1, 2, 3, 4, 5. 5 to 4, which is here. So it's going to look like that. Do you see how the slope is slower here and then it's like much more vertical this way? If you drew it with a more exact way, you would be able to get better numbers. So that's why your answer for 2.1 is E. Any questions? I'm going to do the other ones faster, but the first ones I wanted to kind of slow down so people understand what is happening. So for the same exact thing then, where is the velocity versus time at? Okay. For the velocity versus time, these are two straight lines, right? And you're taking the slope. So if you're taking the slope, it's going to be a constant a horizontal line for VT. This is 2.2 now. Now I'm doing 2.2. Okay. They're both, first of all, you need to ask yourself, is it a positive slope or a negative slope? Those are both positive slopes. So it's going to only be over here. And this is a less steep line. So it will be at a lower point until t equals 3. Okay. And then from t equals 3, it's a very steep line. So it'll be like this. So that answer would be C. Does this make sense? Okay. 2.3. Okay. If you have any questions regarding these questions and you want to see it written out, just ask and I can explain if you want. You know what I can do? I think what I can do is maybe have you guys look through it, because going through all 25 problems will be quite a lot, more than I would like. So maybe I can take questions for you guys, like look through it right now and then tell me if you have questions on the ones you want me to go through. That might be better. And then I will write the explanations and post it. So I do think, but I tried writing the explanations and it got kind of hard for me to do it without, I don't know, maybe Avi's super awesome, so he can, but I had a hard time writing it on the PowerPoint. So, but I'll try again. Maybe it'll work. So does anyone have any questions on the quick check? If not, there is more quick check that I posted. So it has like 15 more problems than the ones you guys did in class. So you guys can work on it as an extra thing. I'll go over 2.3. Okay, I will go over 2.3. Can you do the ones with the 2 different curve and you need to determine whether they have the same velocity and acceleration? Okay, I'll try to find that, Jessica. If you can go to Google Classroom and find, I just uploaded the PowerPoint. If you can tell me what number specifically, it will help me so much. Okay. But Roya, I will do 2.3. Okay. So 2.3 is actually the same deal. So 2.3 is like, it goes backwards, right? Yes, it goes backwards. So 2.3 is, this is 0. This is x, and then it goes from like, so all these dot diagrams, I will put numbers because it's far easier when there are numbers, in my personal opinion. So I could be like 2, 4, I know it's not up to scale, 7, 8, 9. Okay, this is my, hold on. So it goes t equals 0, 1, 2, 3, 4, 5, 6. Okay, that's my time up top, and then this is my x on the bottom. This is blind to this. Okay. All right, 2.9 and 2.10. All right, got it. I will give you 2.9 and 2.10. Yes. All right, Avi might be able to get it, and if you get it with Avi's explanation, you can let me know. I can still do it for the students who may have questions. But let me do Roya's stuff first. So this one is asking for the, after you get the motion, you're getting basically the velocity, correct? Okay, so when you're getting the velocity of this, it's going in this direction, meaning that the velocity will be negative. Okay, so by that, you know it's going to be either B or D. Okay, and you know that the difference, just like the one in the top, velocity basically means the change in displacement. Velocity's definition is change in displacement over time. So if this is bigger, velocity will be bigger. So, but in here, the displacement is smaller, right, over time. So that means in your velocity versus time graph, it will be smaller. And then in your, from until what? Until 3 seconds. And then from 3 seconds to 6 seconds, it's going to be larger. because the distance here is bigger. So it'll look like that, which will give you the answer of D. Does that make sense, Roya? I'm waiting for Roya's response. I hope she didn't leave. Yeah, it does. Okay. We good? All right, excellent. Oh, I know some students have questions about 2.7, so let me do 2.7. Oh, actually, it's not that many, I guess. But, all right. 2.7. But 2.7 was one that I think I heard a lot of what when we did it. So I will do this one. 2.7 is, what does it look like? It looks like this with x and t. And then which velocity graph goes with this type of a graph, right? Okay, let me look at my explanation so I'm not lost. And so in this one, what you are doing is basically this looks like a straight line from here to about here, right? So then in your velocity graph, that part is going to have a constant value, right? And it's a positive slope. So it'll be about here. That's kind of ugly, but you get the point. And then from here to here, the slope is slowly decreasing, right? Going like this. So it's flattening out, right? So it will look like this. And so it's C. For 2.7, the x-axis, yeah, the x-axis is higher. It's okay. It doesn't really matter though, because it's just reading trends. Are we good for 2.7? That's how you read it. So you just read slopes. 2.9 and 10, just so that we're clear. 2.9 and 2.10 are the same exact deal. So I will just explain one, and then I think, actually, it's totally related to this. So in that graph, 2.12. Okay, so that one we haven't done yet, but I'm happy to do it. So this is 2, and then this guy is 1, right? And they're asking you, this is at time t. They're asking you, so at what time, if this is x and t graph, do they have the same velocity? This one has the same velocity all around. This is a constant velocity. It's going to be a flat horizontal line. So if I was to transpose it at vt, it's going to have some sort of positive slope. So that's number 2. Okay. All right, let me divide this. Okay, this is 2.9. Okay. And then number 1 is going to have a slope that's going to be positive, and then it's going to be a negative number. So it's going to, hold on, positive, and then it's decreasing. So it's going to be from a positive number, probably from up here, to like a negative number. So it'll go down to 0. Yeah. And at one point, they're going to meet. Okay. They're asking you, where is that point? Okay. This point is where this one is parallel to 2. Because velocity, you find, is the tangent to x over t. But I did all of them, so it doesn't matter which one we're doing. Okay. Jessica, are you good for 2.9 and 2.10 before I move on to Priyasha's 2.12 problem? Oh, yeah. 2.12 is, I think, a badly written problem, and I try to change it so that it's better, but I don't think it got that much better. So this problem has like a particle that is moving at v1 from point 1 to point 2, and then it has an acceleration of 1. And then it's asking, okay, so as it reaches point 2, what is its like velocity going to be? And it has like a couple options. I will write this one because some of you I haven't seen it. So this is the velocity vector. And then some of them is like this. C is like V is 0. And then D is like going up. And then this one is going super up at the same magnitude. So this is like V. So this is all at 0.2. Okay. So as it's going down, when it is at velocity, when it's at 0.2, what is happening? Okay. Because you know that the acceleration is going the other way, you know that it's going to slow down. Okay. So it can be B, C, D, or E because it goes in the opposite direction of V1. It just cannot be A. The most probable one is B because this magnitude is not that big, but that's arguable because there's no numbers on this. So that's why B, C, D, E is still possible. It's just not A. Because A, if it was going in the same direction, the acceleration would speed up like this. So it would go in this way, but it's not. Oh, I forgot to change the answer. That's wrong. My bad. It's A. Yeah. Yeah. Because the answer used to be like, which one is the most possible? And the answer is B. But technically C works, D works, E works. It depends on what number. So I was like, never mind. So the one that is not possible is A. Yeah. The answer key is wrong on that one. Because I changed the problem. Forgot to change the answer. Good catch. Let me change this. Okay. We good? Any others? Okay, then let me quickly talk about how to do like problems in like 2.6, 2.7, and then that will be my last thing. And then I have to exercise and then do your stuff by going to Monte Vista. Okay. I don't actually know if they closed the gates. If they did, I will find a way. Okay, so tricks. Not really tricks. This is actually how you're supposed to solve all the problems. So going back to the problem of the book. There are 5 equations that you must know, but it's really actually only 3 because you really are only using 3. But some students were asking, like, out of the 3, how do I know which one I'm supposed to use? So I will give it to you. I don't like this question. I want a question that's not that long. Okay, I want this one. Okay, so you can probably go to their place in the tennis course, probably for the track. I actually do something else, but you're going to Monte Vista at night. I have been there at like 4 a.m. before. So for stuff, both as a student and as a teacher. But anyway, kinematics equations. Okay, kinematics equation. There are 5 that they have listed, and it's actually in your book. It's on page 56. But I will list them for you anyway, just so you have them. It's x equals xo bt. Because that lady gives you so many equations and stuff. But I mean, they're all important. I guess if you know all of hers, it's not bad. But that's a lot of equations. I will teach you how these are derived later. But to be honest, on the AP exam, first of all, the equations are given. So you don't really have to know how they're derived. And the second thing is that you don't have time to derive it. So you should know for your own knowledge, but you should memorize for these. Or you don't have to memorize, you're given it. So it doesn't matter. These are barely used. It's these that are used the most because these use the average velocity and we don't usually deal with that much. So these are the 3 that you will use the most in your velocity. Are they given on the test? Yes, they are. Okay, so how you know which one to use is they're all missing one variable. So there is 4 or 5 different types of variables. There's v, which is your final velocity, x, t, and a. There's 5 variables, and each equation is missing one. So this one is missing displacement. So if you're not given a displacement, don't use this one. And then if you're missing, this one is missing, what is it missing? Oh, the final velocity. So don't use it if you see final velocity. And then if this one is missing time. So if you don't see time, don't use it. That's really how it works. Yeah. So to give you a problem and how you're supposed to do these problems, the way I like to do them anyway, is first of all, pretty soon you're going to have to draw a force diagram. For now, you are not required, but not drawing them will get you to it in a bad habit because you cannot solve force stuff without force diagrams later. So it's important to draw what you have. So the problem for this one, I'm looking at problem on page 58. And the problem goes, there's a car that's trying to go onto a ramp of 200 meters. And its initial velocity is at, VO is at 200 meter, oh, no, 200. VO is at 10 meters per second and accelerates at 2 meters per second squared. And they're asking you about 200 meters, how long it's going to take you there. So they're asking for time. Okay. First, the very first thing you must do is make sure that your units are aligned. Okay. So make sure your units are aligned. Then when you see that you have to find out which one you're missing. The one that you're missing in here, and so you should write down all your variables on the side and draw a diagram. The diagram is important, not for here, but for like within the next chapter, it will be very important. And so the one you're missing, you have to find the equation that is missing final velocity. So the equation I will be using will be this one. X equals XOT plus VOT plus half AT squared. And my XO would be 0 because it starts at 0 usually for position. That means this is out, and then you get to basically solve it according to this, and then you'll find your T. Okay, I don't think I need to solve it, but I just wanted to show you how to pick which equation to use. I hope that helps. 2.6, 2.7, we will do more of tomorrow. You need to hear more of me. Okay, any last minute questions? Anything? Before I go, oh my life, my knees. Okay. Oh, that feels good. Okay, any questions? Before I leave and take off and say bye? Okay, no questions, it seems. Have a great rest of the night. And I will see you tomorrow. Well, yes, I will see everybody tomorrow. Okay, bye-bye.